Well, I've got all three of my green matrix displays set up now. I put the straight headers on the back finally, and for now I'm using DuPont cables to go between them, and that way I can position this however I need. Doing it zigzagging is one way to fit it all in. So this week's mail includes another trip to the dollar store. I went there just for a couple of simple things, and I ended up buying some more tool and part storage trays. I thought this was neat because they're stackable if I want to just keep them up on the shelf, but I can then pull them down and they're transportable, parts won't fall out, and there's some nice small little storage areas, whatever I want to put in there. So if I'm working on something, I can put a handful of parts in there. If there's anything static sensitive, I would probably get some conductive foam. I could put some common bolts, screws, nuts, washers, whatever, mechanical fastener type items. I could store extra soldering related materials if they're small enough to fit in there. And it just snaps down and can store out of the way. $2.50 at Dollarama. And for $4 I got this little toolbox. I just wanted something simple. So this one has a top storage tray as well as the regular inside. And it has this area on the top for a couple of loose items. Of course, I wouldn't trust this lid to stay down if I want to open the bigger lid. I'd probably want to make sure I hold this or else don't put anything like a whole bunch of tiny parts. But it does snap down relatively secure, at least for now. It may wear thin. So I can put some common things in here, including maybe even one of those cheap multimeters, a few standard screwdrivers, maybe one with interchangeable bits, and a few common sets of pliers, wrenches, and then just keep this in other areas of the house because I'm constantly running up and down 2 flights of stairs and I can't find anything. I just want something handy. So for $4, that's okay. And these types of stacking bins with the sloped front access, these are always useful. 3 of these are $4, and the plastic quality is better than I would have thought, which is one of the reasons I decided to get these. You know, it's not going to be totally rigid, but it's also not that cheapest kind of stuff. In fact, I have this smaller one that I've been cramming all of this stuff in, pliers, wire cutters, desoldering tools. Needed something bigger. What is this? See how junk piles up? What are these nails doing in here? So now this has a lot more room to get more junk in it. Oh, there's the IC extractor. Some other things I got here. Hook and loop, Velcro type fasteners, $1.25 for the price. I'm sure this will come in handy. Anti-slip carpet tape. It really does seem anti-slip. It feels like rubber. So if you have one of these little carpet rug things on a smooth floor surface, wood or ceramic tile or something, and this rug is sliding around, you can put some of this in little areas, maybe just on each corner. But also it's probably just grip tape that can be used for almost anything else. And a solar fence light. I think this was also $4, which I felt was kind of expensive, but I wanted to maybe later do a teardown on this. I'm wondering, does it have only one AA battery in here? It doesn't really say much here. But the reason I wanted this in particular, when I take it apart, I want to see how much available space is inside here, because if I want to do some outdoor solar experiments, something like this, if it's already semi-waterproof and I can just mount it somewhere, have the solar panel, and fit some electronics in here, I figured it would make a good outdoor solar charging case. So that was my quick trip inside the dollar store, and that's not even all that I got, but that's all that's workbench related. So now let's open some mail. Here we have an expansion board module. Good way to start. So this is loosely wrapped in foam. Oh, it looks like an ESP module. So I've been ordering more modules like this, including, I'm still waiting for a NodeMcu, but I think, yeah, this one says D1 Mini WeMos. ESP8266, and a CH340 USB interface. I think I'll put some header pins on right now. Lined up the pins by plugging it into a breadboard. That should hold up. WeMos D1, NodeMcu, Lua ESP8266, ESP-12F, Mini Wi-Fi CH340 development module board. US $3.04 from World Chips. I got mine at auction for $2.10 US, and it took 3 weeks to get here. So similar to the NodeMcu in terms of having an ESP8266 module on there. Nice breadboard friendly pins to get power and I/O access. USB interface here to program it and power it. I've already used one of these to do a Wi-Fi YouTube subscription counter. Just another form factor of ESP8266. This says LED grid. So I wonder, is this the other? I ordered two little 4x4 WS2812s in one lot, and then I ordered another lot. I can't get this out. Oh, okay, so the package itself is bubble wrapped, but the inside of the envelope is bubble wrapped, so I was pulling that. So as I was saying, yeah, it looks like these are the other two 4x4 WS2812s. And we tried these out recently. We have 16 WS2812s. They are wired in a zigzag pattern. So data in is over here, data out is over here if you want to add another grid. So now that I have 4 of these panels, I can do 8 by 8. The only thing I'm wondering is, if I arrange these in a grid now and I want to wire them all together, I don't know if there's drivers out there meant for these kind of layouts, but I might have to do something custom if I'm going to cascade these. You can get individual ones, I'm not sure all the sizes, but say you can get an 8x8 single board like this. It's probably going to go straight across 8 and then up and straight across backwards 8 and then zigzag that way. Whereas if I cascade these smaller ones, it's going to go part way over and do the zigzag, and then wherever I wire it next, it's going to do a little zigzag, and then I got to bring it wherever else. So I'll have to think about that. Maybe I need to actually use these just as smaller individual grids. Maybe I can just put these inside, like, hey, I could lay this at the base of something and let it diffuse RGB light up into some project box. Things like that. We'll see. 4 1640 64-bit WS2812 Matrix LED 5050 RGB full color driver board for Arduino NU. The 16 LED version, $1.90 US from Survey 2014, 4 weeks to get here. So they have up to 64, which would be 8x8. I still have to figure out what I want to do with these, but I wanted them. Here's all the info on WS2812 LEDs, a project for another day. Expansion board module. And this, I see, yep, potentiometer knob, okay. I ordered some of these linear slide pots. I already have 2 that I ordered long ago, over a year ago, and I was recently using these on a DMX controller, and I thought it would be nice if I had 3 so I could do red, green, blue, and I'd still want another one actually for maybe overall brightness. But back when I was looking at these, I did another video. The way there's 2 potentiometers, so you have 2 sets of pins here, it wasn't very clear how these are supposed to be wired, and also the taper on the pot. Was it linear or logarithmic or something else? And here's the drawing I came up with. So it looked like on the 3 terminals, from left to right, they are labeled ground, VCC, and then out for A and B. So after investigating this, I found the grounds are common, the VCCs are independent, and the output wiper on the pot are independent. And the other thing I saw, this is sort of an S taper, which I believe somebody had commented is used maybe on mixing board consoles. So you have a certain amount of resistance change near the top and bottom of the pot, and then more toward the first quarter through the center and up to 3/4 is a different taper. So it wasn't linear, like you go 25% and you get 25% resistance, 50% is 50% resistance, and so on. So I want to compare this one I just got against these other two. So I'll keep these old ones together so I don't get this confused, and the new one is on its own. So between the two pots, if I measure ground and ground, less than 1 ohm, so those are common. VCC on one to VCC on the other, 20K, so that's not common, which is good. So from this point to this point is 20K. That makes sense if these are 10K pots, because we're measuring from here through this common ground up to here. So it's a 10K in series with a 10K, that's good. And of course the outputs, with the slider all the way one way, I'm getting basically just 1.5 ohms. So if I turn this all the way the other way, 20K. So that's from output to output. So measuring wiper to wiper with the pot all the way to the left, I'm basically measuring directly from this ground terminal to this ground terminal. So that makes sense, it's 1.5 ohms. When the pot is all the way the other extreme and I measure wiper to wiper, I'm measuring through the whole 10K common ground all the way through another 10K. So it makes sense I saw almost 20K with the wiper up here. So how about the taper? So the pot is all the way to one extreme, and from ground to out, it's 9.68K, almost 10. If I go what looks like 1/4 of the way, it's only barely changed, 9.39K. So that's that S taper. It's barely changing in the first quarter. Now if I go halfway, we're about half of 10K, 5.48. So starting on the other side, of course, from ground to wiper, it's going to be basically nothing, 1 ohm. So I'll go 1/4 way up for about 400 ohms, we'll say. So now I nudged it just a bit and it's gone a whole lot. A slight nudge and it went from about 400 ohms to 900 ohms. So that's that S taper. It barely changes at the extremes and then it changes a lot in the center. 10K linear slide potentiometer module, dual output Arduino AVR electronic block. US $1.70 from Alice 110-1983. 4 weeks to get here. I paid $209 Canadian. So this linear word being thrown in here has been a source of confusion for people because linear could refer to the taper of the potentiometer, where as you incrementally go from min to max on the slider, you could linearly go min to max resistance. Linear, I guess they mean it's just a straight line slider. So it has two 10K pots controlled simultaneously by the one wiper. They're just throwing out there. You can use it for 3.3 or 5 volts, obviously, but what's the power dissipation? I would only be using these to do things like give an analog signal into a micro or an op amp or something, so it's not going to draw much current. And here's a potentiometer resource I looked up in the past, showing several taper curves here. So it looked like this S taper is what these potentiometers have. So when you go from one end of the slider up to, say, 25%, you've moved less than 10% of your resistance, even though you've gone 25% of the distance. IC chip 6502. Obviously, that's a 6502 processor. And I ordered this, just like I ordered a Z80, and I know I've ordered a few other things, but I can't remember what. I just wanted to get some of these old processors, and maybe I can figure out, first of all, how to get them out of this package. Maybe I can figure out how to use them, just even for something simple on a breadboard. It'll be fun to use one of these huge, is this a 40-pin dip? R6502AP, made in Mexico. And I'm not sure, is this the date code? Was this made in 2012, 40th week? Sometimes it's hard to tell what all the different sets of numbers really mean. One pieces, R6502AP, Rockwell CPU, 6502 DIP 40IC chip, US $1.90 from Global Electronics 1. took 6 weeks to arrive, and as with most auctions for ICs, there's no other info on this listing. MOS Technology 6502, an 8-bit microprocessor introduced in 1975. And this was made to be a low-cost processor and caused a lot of price decreases. So being cheap, now more hobbyists could afford to play around with processors. A bunch of projects started a home computer revolution in the early 80s. The Atari 2600, Apple II, Nintendo, Commodore 64, etc. used 6502 or variations. Original NES is where I first saw the 6502 back when I took it apart for the first time. One of the manufacturers is Rockwell, and that is the logo on the chip. Whether it's genuine or not, who knows? And there's a 6502.org site, a resource for people interested in building hardware or writing software for the 6502. I haven't looked through this site, but good to know there's resources for when I get to play around with this. LED module. So then, LED, no. That is a breadboard power supply. So this plugs into a breadboard, an LED, a switch, and jumpers between 5.5 and 3 volts on each side, each rail. So this snaps in on the rails of the breadboard very nicely. In the right light and focus, we have two 1117 regulators, a 5 and a 3.3. So I'm going to try to find a DC adapter. But I don't know the maximum DC in, so first I'm going to look up the datasheet on this, see what I'm allowed to give it. So if I'm allowed to put 15 volts into these regulators, I have a 9-volt battery and a case with one of these DC plugs on it. So now I just need to make sure the polarity. The battery is center positive. Ground is this terminal right here. So on the socket, ground is the outside, so it's center positive as well. Should work. I have the probes in the breadboard with ground and VCC on this regulator here, and the jumper is in the 5-volt position. So I'll plug in this 9 volts, turn it on, and I got 5.00 and the LED is on. I have the top rail set for 3.3. So if I just bring the positive probe up to the top, there's my 3.3. One Piece's board MB102 breadboard power supply module 3.3 and 5 volts for Arduino. US 99 cents from Satisfy Electronics. 4 weeks to get here. I got mine at auction for 89 cents Canadian. Input voltage 6.5 to 12 volts DC or a USB supply. Output, you can switch between 3.3 and 5 volts on both rails. Maximum current out less than 700 milliamps. I wouldn't be trying to stress this module out anyway. So I think this is pretty good for $1 or even less at auction, so I'm definitely going to be looking for more of these. Well, that's a lot of stuff for one mailbag. Looks like I'm going to have a lot of stuff to work on soon. I want to do some outdoor gardening projects, so that'll be time sensitive. And I can get back to some DMX stuff. I can do some more breadboard prototyping, some more NeoPixel stuff. So thanks for stopping in, checking it all out with me. Special thanks to all my Patreon supporters. All of your contributions help make all of this possible. Keep checking back and see what I get up to with all this stuff.